Hello, everybody. Welcome to today's lesson. My name is Pathman Math, and I'm coming back to you with a new series that I'm going to be discussing with you guys. So, real quick before I get into it, what we covered previously, we had dealt with logic and patterns, and we had started to discuss functions. And what functions or equations are is basically you are solving for a value when you plug another value into that equation. Okay? So you will hear these interchanged out between equations and functions. Um, they have different types of roles, but in certain contexts, they are exactly the same. An equation is a function. Okay? So with this new series I'm going to work on, I believe it will be about 3 parts or so. And I'm just going to be covering part 1 today, um, getting a bit of an introduction into what a function that I'm going to be discussing is in the context of what we are going to be learning for this. Okay? So, from previously, you had watched me discuss equations in terms of rules for patterns. And essentially, taking those patterns and applying it into what we are talking about now is basically what a function is. Because we are going to get a series of numbers, series of values here that follow this specific rule, this pattern, this equation, this function. Okay? So, as I discussed previously, we had an equation that followed the form of y equals ax plus b, okay? Where y is going to be the next number in the pattern, x is the current number in the pattern, and a and b are two constants that follow certain things where b was the pattern constant and a was the scale, okay? So I'm going to rewrite this equation. It's going to be the exact same type of equation, just written a different way and putting labels to these values in a different context. It's still the same thing. We're still dealing with an equation here, but we're now applying it as a function. Again, same type of thing, different context, but it's going to be running the same way. Okay? So, where y was the next number and x was the current number, and then we had our two constants here, we're going to write this as f parenthesis x parenthesis equals, I'm going to do mx plus b, okay? Now, f of x is what we call this, the f with the parentheses around the x. We are going to take this and have this as replacing the y, okay? The m replaces the a, but it's still a constant. It's still a scale that is going onto the x value that we are working with. And then b is our, in a sense, pattern constant is going to stay the same no matter what we do. We are just adding it or subtracting it to what happens with the mx here. Now, this is written as f of x, or a function of x. And you are going to be getting these specific x values from a table of values that we will have to create, okay? Where you take a number of x, okay? X is referring to a certain value. You take x inside that table, and then you're going to plug it into this function, okay? Then, once you plug that in, you solve the equation, solve the function here, and you get the f of x, which is going to be the next value, okay? It's going to be what, when you plug x in, that's the value we get for that function, okay? Now, I'm doing this bit of intro here because we're going to be leading into from functions to derivatives. We have to deal with these derivatives at some point in your schooling, and I'm going to just do a quick bounce from one to the next because you can do that, and these lessons will be meshing together, leading from one to the next. So I'm just going to give you guys a bit of an intro here, get you started with it, and work our way into talking about these derivatives. Okay? So pretty straightforward. A little bit of vocabulary here, if you will. But f of x, that is what this f with the parentheses around the x, because we are going to be taking certain values and plugging it into the x here, plugging it into this x here, and then we solve the function, solve the equation for our next value in our table. Okay? So, I'm going to erase this real quick. Move on to getting some examples here for us. So, typical table that you will see is x at the top, and then f of x, okay? Function of x, all right? Now, usually the values you will see, because more often than not, when you are dealing with these types of functions, you're going to be having exponents attached to the x. So these functions are to graph graphs. Okay, so you'll have your graphic, you have your x, which is your horizontal, and your y, which is your vertical, and you're going to be plotting points on those graphs using these types of functions here. So in order to be able to get an accurate depiction of a graph, the values that we typically choose for these types of equations, these types of functions, is typically -2, -1, 0, 1, and 2. Because your starting point on a graph is at the 0, 0 mark, where your x is 0 and your y is 0. Okay? Then you're going to look at both sides of the y-axis to see how the function is going. So if you have a standard equation where it's just x with no power, or in this case, power of 1, and there's a linear function, but you want to make sure you figure out which way the linear function goes. Okay? It's because it's going to be a straight line, linear. Okay? Now, other times you may have more powers, such as to the power of 2, which we talked about last week, which then create other types, other shapes of graphs. So we want to make sure that we look at both sides of what's called the origin of the graph in order to then find the values of our function and see how this function actually looks like on a graph. Okay? So typically your values will be -2, -1, 0, 1, and 2. Now, when you write out the equation here, remember it's f of x equals, and that's your mx plus b having a different scale here. So I'm just going to come up with a random equation for us to work with. I'm going to say 2x plus 3. Simple equation, okay? Now, what we're going to do is we're going to take our values here, the x values of -2, -1, 0, 1, and 2, and we're going to take each one individually, plug it into our function, and then solve for that function, okay? Now, the way we do this, the way we write this, is we do f of, instead of x now, we're going to plug in our first value, f of -2 equals, now, since we no longer have an x, we have a -2, we're going to plug the -2 in for x. So we have 2 times -2 plus 3. Okay? Now, with this, we then solve. We had to distribute the 2 to the -2. And by distribute, I mean multiply. Okay? Anytime you see a value closed off inside of parentheses, you then do multiplication. Okay? So 2 times -2. Remember, it's negative. So we have -4, because 2 times 2 is 4, but it's -2. So it's going to be -4 plus 3. Now, negative 4 plus 3, or in a way that we can look at this, 3 minus 4. It is the exact same problem. We're just moving the values around because with addition and subtraction, you can do that as long as you keep the signs where they're supposed to be at, okay? So negative 4 plus 3, or in this case, 3 minus 4, we are still going to get a negative 1. So we fill in our negative 1 for our f of negative 2 part of the function. Now we move on to the next one, okay? Now instead of negative 2, we're going to be plugging in negative 1. So f of negative 1 equals, plug the negative 1 in for our x, okay? So we have 2 times negative 1 plus 3. Now again, we distribute, which is just multiplication for this. So we get 2 times negative 1, which is just negative 2, because again, we talked about with the multiplication tables, whenever you multiply any number by 1, it's going to be that same number. But now we have a negative 1, so it's going to be a negative version of that same number. So negative 2 plus 3, or rewrite it as 3 minus 2. It's going to be the same exact value here. So 3 minus 2, positive 1. Easy peasy. Simple order of operations here. Doing addition, subtraction, doing multiplication here. Very, very easy stuff. All you need to do is just keep track of how you write out these equations, write out these functions, and then you're just plugging in these values. Real easy for it. Okay, so going to erase this, move on to the next one. So now, to keep the equation up here, that was my bad. F of x equals to 2x plus 3. Okay, so now we're plugging in 0. F of 0 equals 2, 0 in the parentheses, plus 3. Now, anything times 0 is going to be 0. So this 2 distributed to 0, or 2 times 0, bam, cancels out, because anything times 0 is just going to be 0. Boom, we just get 3. Okay, so easy peasy for this. Fly through these last ones here. F of 1, we plug in our 1 for x. Sorry, a mild alarm on my phone. So 2 times 1 plus 3, we get 2, because again, any number times 1 is still going to be 2, or still going to be that same number. So 2 times 1 is 2, plus 3. Simple and easy, 5, boom, we're good to go. Now, final one, f of 2. We do 2 times 2 plus 3. 2 times 2, we got positive 4. 4 plus 3, we get 7. Boom. We have our function here for these values. Now, this function, this is just for 5 numbers, because if we were to then graph the function, then we could see what the function is going to look like on both sides of the origin. But you can continue on with more values. We can go further backwards, go negative 3, negative 4, negative 502, all the way that way, and see what our value is, because then all we do is we take that value of x, plug it into our equation. Because unless we specify that a graph is going to end, it's going to go on infinitely, so we can plug in as many numbers as we want into these functions, perform the operations, and get a value for that function. Okay? And instead of going the negative route, we can go to positive 502. Keep going that way. So we just list these few numbers as just values that we can plug into our function to get an idea of what the function is going to look like if we were to graph it. Okay? We just plug in these values in, and then we're good to go. All right? So, quick and easy for that. I'm going to do a little bit of a harder example. So, clear this out. And remember, we're looking at both sides of the graph that we would use if we were to graph it. And now we use these values, but we're going to have a different function. So I'm going to say f of x equals, and let's say 3x squared minus 2. Yeah, that's fine. Let's do 2. That's fine. Now, in this case here, we have an exponent. We have a power of 2 around the x. So following the order of operations, the PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction, okay? We have to, once we plug in our values here, perform the exponent here, because that's the first step of our order of operations, perform the exponent, then we work through the rest of the order, okay? So we have f of x equals 3x squared minus 2. So I'm going to plug in our negative 2 here, and we have 3 times negative 2 squared minus 2. Now, with a power of 2, that's basically saying that whatever number is inside this exponent, we're going to have 2 of, and we're going to multiply them together. Okay? So essentially, this is 3 times negative 2 times negative 2 minus 2. Okay? So we need to keep performing stuff. Now remember, PEMDAS, parentheses first, we have these parentheses here. We perform everything inside the parentheses. So we have to multiply these two values first before we do anything else. So we get 3 times, now negative 2 times negative 2. Big rule here goes with any type of math. Anytime you multiply a negative to a negative, double negative there, becomes a positive. Okay? So, essentially, negative 2 times negative 2 is basically the same as positive 2 times positive 2. In this case, 4 minus 2. Now we do our distribution here. 3 times 4, we get 12. And then minus 2, and we get 10. Following our order of operations here, able to easily solve this function here with plugging in the value of negative 2 in for our function. Quick and easy, boom, 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 followed our order of operations, found our value for our function by plugging in our x value. Now, next one, keep it going here because we got to get the rest of these values for our little table. We have f of negative 1 equals 3 times negative 1 squared minus 2. Now remember, squared, that means we have 2 of the same value here. We got to multiply them together. And as we saw with the negative 2's, we're going to have negative 1 here multiplied to itself. So essentially, negative 1 times negative 1 minus 2. That turns into positive 1 times positive 1. So we get 3 times 1 minus 2, 3 minus 2, and boom, we got ourselves a positive 1. Bam. Quick and easy for it. Following our steps here, our order of operations, making sure that with the double negatives there, when they're multiplied together, they become positive. Okay? So, double negative, you multiply them together, turns into a positive, a plus. Two minuses, bam, plus. All right, next one. F of 0 equals 3, 0 squared minus 2. Now remember, anytime you're multiplying 0 to anything, it's just going to be 0. So in this case, we have 0 to the power of 2. That's 0 times 0. That's still going to be as big old 0. And then we've got a 0 times a 3. So 3 times 0 squared, this all just cancels out because that's just a bunch of zeros multiplied together. So then all we have left is a minus 2. Quick and easy. You guys are doing great looking through this stuff. See, it's this stuff, when you first look at it, it may look a little confusing, but it's not that difficult. It just takes a little bit of practice, and you'll start to see the patterns like what we talked about last week, the patterns of how you can go about solving this different stuff. All right, so now here's the biggie. We have f of 1 equal to 3 times positive 1 squared minus 2. This looks familiar because when we had negative 1 and we squared it, it became positive 1. So essentially, this right here turns into this equation here. We get 3 times 1 minus 2, and we get 3 minus 2, and we just left with our 1. Exact same value here, because when you're dealing with a squared function, that's what it's called when you have a power of 2, a squared function, any value you plug into that square on either side of the 0, on either side of the origin, it's going to be the exact same value there for the y, because when you square a negative value, it becomes positive. So then that's going to be the same value you see on the positive side of the origin. Positive side of the origin, negative side of the origin, it's going to be the same exact value because you're basically canceling out the negative by squaring it. So for f of positive 2, we plug in, mess that up there, 3, 2 squared minus 2. This turned into the same problem that we, or the same function that we had back here. So this whole thing, bam. In actuality, we only had to solve 3 values of x because then we can just match it to the other side. Once we saw what negative 2 and negative 1 were, we could plug that in down here because we're squaring a negative. It's going to be the same value for this function. Whether it's positive or negative, it's going to turn into the same value once you're on either side of the 0, on either side of the origin there. So now we have our values here in our table. If we were to graph it, it's going to look like a curved function called a parabola. It basically just looks like a v/u that has a point somewhere on the origin, in this case at the point 0, negative 2, and then it curves upwards very quickly, and it's going to have the same values at each of these different, same f of x values for every single x value, okay? Because we're just matching, like I said, whenever you square a negative number, it turns into a positive. 2 negatives become a positive. So boom, quick and easy for this. This is how you solve functions. You get your table set up, you plug in your values of x into your function here of f of x, and then you just order of operations. Boom, boom, boom. You solve it. You get your values here, and then you can then graph those functions and get the different shapes based off of what we've got for these powers here. Big thing with functions is the power that surrounds the x. Okay? Because if we were to go higher, instead of doing a power of 2 and do a power of 3, it's going to look highly different when we graph it, and the values we get are going to be all over the place. But don't stress about it. That's the biggest thing. Keep your cool, keep calm, keep collected, and you will be good to go. Like it may have looked difficult at first just seeing this for the first time, but the steps we took, it was easy. Just you plug a value in, you do the order of operations, you solve, and you're good to go. So that is an introduction to functions. Okay. Now, next week, we're going to go into talking about derivatives. Okay. Now, derivatives are basically a way of changing a function off of its power into a lower power function. Okay, I'll go more in depth to it next week because don't want to get too far into it right now. Taking up enough time with talking about functions. So we will go on with derivatives starting next week. All right. So I appreciate all you guys for stopping by, hanging out, wanting to learn math with me. Appreciate all your guys' support. If you have any recommendations, any requests for lessons in the future, like I said, I'm going to do this. Probably going to be doing 2 more videos, continuing on with this series here. But if you have any requests, any recommendations for certain types of lessons that you're wanting to see, certain topics, whatever you want, ask me. Ask in the comments down below, and I will do my best to help you guys understand these topics a little bit better, give you guys a little bit more time to work with stuff than what you may not get from being in school. So ask your questions, ask away. I'll be more than happy to answer you. I'll be more than happy to create new lessons based off of what you guys are wanting to learn. I appreciate you guys. I'll catch you in the next one. See ya.